Advanced rigging. Up to this point, we've covered the fundamentals. You understand equipment. You understand knots. You understand basic rigging techniques. Now we're going to take the next step, because advanced rigging isn't about doing something completely different. It's about understanding the same system at a deeper level. In this podcast, you'll learn how rigging point placement changes everything. You'll understand how forces behave when using multiple blocks and redirect rigging. You'll learn the principles of bend ratio, moment, and mechanical advantage. And you'll learn how to choose the right techniques when obstacles limit your options. Let's start with rigging point placement. One of the most important decisions you make is where to set your rigging point. Above the piece, or below the piece. When the rigging point is above the piece, the system behaves more predictably. As the piece is cut, it begins to fall. The rope engages quickly. The distance of freefall is reduced. And the forces are generally lower. This is often the safest and most controlled setup. It allows the climber to guide the piece using a hinge and control its path more effectively. Now let's look at what happens when the rigging point is below the piece. In this setup, the piece falls past the rigging point before the rope engages. This increases the amount of freefall, which increases acceleration, which increases momentum, and ultimately increases force. This is where dynamic load becomes a major factor. A dynamic load is a force created by movement. And when a piece drops before being caught, that load can multiply very quickly. So why would you ever rig below the piece? Because sometimes you don't have a choice. Obstacles, tree structure, or access may limit your options. But when you rig below the piece, you must compensate. You may reduce the size of the piece. You may increase friction. Or you may change your technique entirely. Now let's talk about redirect rigging. Redirect rigging uses additional blocks or pulleys to change the direction of the rope. For example, you may set an anchor block high in the tree, then run the rope through a second arborist block or pulley at a different location. This allows you to control where the load travels, but it also changes the forces in the system. Every time you add a redirect, you introduce new forces. At each block, there is an input force. That's the force coming into the pulley. And there is a reaction force. That's the force applied to the anchor point. In many cases, the reaction force at a redirect can be greater than the original load. This is why anchor selection becomes even more critical in complex systems. Now let's talk about the fishing pole technique. The fishing pole technique uses the flexibility of the tree itself. You rig a piece in such a way that, as it is cut, the branch or stem bends under load. That bending absorbs energy. It reduces the shock load on the system, and it allows for a smoother transfer of force. But it also introduces moment. Moment is rotational force. It's created when a force acts at a distance from a pivot point. In rigging, moment is what causes branches to bend, swing, or rotate. The longer the distance between the load and the anchor point, the greater the moment. This is why long limbs can generate significant forces, even if they are not extremely heavy. Now let's talk about bend ratio and bend radius. When a rope passes over a block or pulley, it bends. The bend radius is the size of that curve. The bend ratio compares the diameter of the rope to the diameter of the sheave. A larger bend radius means less stress on the rope. A smaller bend radius increases stress and reduces strength. This is why using a proper arborist block with a large sheave is important. Now let's talk about mechanical advantage. Mechanical advantage allows you to multiply force. In a simple system, the input force is what you apply. The output force is what the system delivers. By using pulleys, you can increase the output force without increasing effort. For example, a moving block system can double your pulling force. This is useful when lifting or repositioning limbs. But there's a trade-off. As you gain mechanical advantage, you also increase the amount of rope you need to move, and you increase complexity. More complexity means more potential for error. Now let's talk about lifting. In some advanced scenarios, you may need to lift a piece slightly before lowering it. This can be done using pulleys, Prusik hitches, or friction hitches like the Valdetane tresse. Lifting can help reposition a piece. It can reduce binding, and it can create a more favorable angle for removal. But it must be done carefully, because lifting introduces additional forces into the system. Now let's walk through a real-world scenario. You're removing a large limb over a structure. You cannot place your rigging point directly above the piece, so you install an anchor block higher in the tree. Then you redirect the rope through a second arborist block. You tie the limb using a tip tie. You add a tagline for directional control. On the ground, your crew sets up a porter wrap, or ratcheting bollard. You make your face notch, then your back cut. As the piece begins to fall, it travels along a vector. That vector is determined by the rigging point and the balance of the limb. The rope engages, the system loads, the redirects transfer force through the tree, the ground crew manages the descent, and the piece lands safely. Now imagine the same scenario without understanding these principles. You underestimate the forces at the redirects. The anchor fails. or the rope experiences excessive wear due to poor bend ratio, or the piece swings unpredictably because the vector was not considered. This is what separates basic rigging from advanced rigging. Understanding. So here are your key takeaways. Placing the rigging point above the piece reduces force and increases control. Placing it below increases dynamic loading and risk. Redirect rigging changes force distribution and requires strong anchors. Bend ratio affects rope strength and durability. Moment influences how pieces bend, swing, and rotate. Mechanical advantage allows you to multiply force, but increases complexity. And every rigging decision should be based on how forces move through the system. In the next podcast, we're going to go even deeper. We'll focus entirely on compound rigging techniques. You'll learn how to build multi-point systems, distribute loads, and manage complex removals. Because advanced rigging is about understanding, but compound rigging is about control at every level. You've been listening to the Arborist Podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time.